Alright, today we're going to be looking at prime factorization, which is also called prime decomposition. So this means simply expressing any composite number as a product of its prime numbers. What's a prime number? A prime number is anything that's only divisible by itself and 1. Every other number is called a composite number. Right, except for 0 and 1. Right, let's get started. So we're going to use a common question here is a factor tree, and they're asking us to essentially break the whole number down, start into its prime numbers at the end. So we're going to start this first one with 18. 18 is then broken down into 9. Both these numbers have to multiply together to ultimately give us our the number at the top. So when we look at something like this, we know that 9 times 2 is going to be 18. So we can do 9 times 2 there. Now 2 is a prime number, it's only divisible by 1 and itself, so we can leave that one alone. But 9 is a composite number and can be broken down further, right? 3 times 3 is also going to produce 9, and 3 is a prime number because it's only divisible by itself and 1, and we just bring down the 2. So when we do prime decomposition, what we end up with is essentially rewriting the original composite number as a product of its prime numbers, right? And this can be made simplified further if we use its index form. Okay, 3 to the power 2 times 2. Super simple. This is kind of helpful for finding lowest common denominators and highest common factors. Alright, so let's look at our second one. We're going to start off with the prime factorization of 50, and they've given us our first breakdown, 2. So we can divide 50 by 2 and then we get 25. Now obviously 2 is a prime number and we can't decompose that anymore, so we can just bring the 2 down to the bottom. After that, we're going to look at 25. Now we know that 5 times 5 is 25, and at the end we're going to have 2 times 5 times 5. Alright? And if we put that in index form, that's going to be 2 times 5 squared. Alright, last one we're going to look at for this type of question is going to be the prime factorization of a 30. Alright, so we're going to start off with breaking it down by 3. So 30 divided by 3 will give us 10. And then we can't break down 3 anymore, so we just bring it down. Then we're left with 2 remaining spaces, and we know that 5 times 2 is going to be 10. And these are 3 prime numbers, and we can't break down any more of these. Alright, so an easy way to tell when you're done, you won't always be given these types of circles. An easy way to tell when you're done is if you can't divide the number any further. Alright, let's have a look at another example. So here's an example of another type of question you can get. They won't give you the tree, and you draw the tree for yourself. So it's asking you to find the prime factors of 180 and 168. Let's start with 180. Let's just break this down into 2. Alright? So, what can we do with 180? Well, we can first know that 2 is prime, so if we reduce it by 2, at least we've got one prime number sorted out. We don't have to worry about that anymore. And let's do the same kind of tree system with 90. We know that 90 is 2 times 45. And we can bring down the 45 and divide that again. Now we know 5 times 9 is 45. Can't break the 5 off anymore. We can do something for the 9, and we know that 3 times 3 is 9. Okay, so if we brought all of this down, our prime factorization, or our prime decomposition, is 2 times 5. 2 times 2 times 5 times 3 times 3, and it's in its index form. It's 2 to the power of 2 times 5 times 3 to the power of 2. Okay, very easy, very simple. Often starting off, if you've got an even number, great place to start, just divide by 2. Let's do the same for 168. I'm going to divide this one by 2, and half of 168 is 84. And then we can leave that one alone. And we're going to look at breaking up the 84. Well, that's just 2 times 42. And if we look at this again, we can do 2 times 21. And if we look at this again, we can do 3 times 7. Alright, so in the end, if we bring every one of these down, we end up with 2 times 2 times 2 times 3 times 7. Or 2 to the power of 3 times 3 times 7. Alright, so prime factorization is really helpful and helps break down numbers into their prime components, and factor trees really help do this visually and help guide you through the process. So that's all we have for today. There's some more videos to watch and practice the questions that are in the lesson.